Hello all. In this video we are going to talk about variables and constants in C++. So from previous video, in order to do cout, right, display something on the screen, for cin we need the IO stream and we need to use the namespace standard. So what we do here is some important definitions and information about the variables first. First thing, as I mentioned, in C++, you definitely need to define the types of the variables. Okay, that's one thing that you kept in mind from previous video. It's not going to recognize the types of the variables just if you type some value for them. You have to say what they are. Second thing is it's case sensitive. Okay, so small a and capital A are not the same for C++. In that aspect, it's similar to MATLAB. Third thing is, if you want to use quotation marks, single quotation and double quotation are different. Okay, single quotation means it's a character, double quotation means it's a string. So you clearly have to know the difference between single quotation and done. You see the colors are different too. Strings are shown with blue and this character is shown with kind of this, I would say, light brown color. Okay, the other important thing I want to emphasize is try to define the variables as late as possible and do not change their types afterwards. So if you call variable a as integer, then in the following code, do not go ahead and say, no, a was float. Actually, it was not an integer, it had decimals. So do not change the type of the variables and define them as late as possible so there is a smaller chance of reassigning them or changing their types or anything. Okay, so first thing, what can we include for the names of the variables? Just like, for example, MATLAB, the only things you can use is letters, numbers, and underscore. You cannot use a dash. You cannot use question mark, exclamation mark, @ or anything like that. And the name can only start with either letters or underscore. So something like, for example, underscore var1 is acceptable. Var1 is acceptable, but one var is not acceptable. You cannot start a name with a number. Keep that in mind. Now, what types of variables do we have in C++? Well, the first one is integer. The numbers that can be positive or negative, and they don't have decimal places. And depending on the implementation of C++, they can have 16, 32, or 64 bits. Typically, they are 32 bits. We have characters, which are only one letter. You put them in single quotation, and they are only 8 bits. For short integers, you can also use this character, but typically we use them only for one alphabet letter. We have string, which is basically placed in double quotations. The color is blue. And they have a bit of 0 at their end to show the end of their basically bits, right? So the last bit of a string is always a 0 to show that the string is over. We have signed and unsigned integers. This signed and unsigned, we call them like adjectives or modifiers. So they are saying that, hey, C and D are integers, but one of them is signed, which means it can be positive or negative. The other one is only positive, right? It's unsigned. And since going positive and negative will make the overall range bigger, so I expect that if they both get 32 bits, then one of them can store between what? Between -2 to the 32 minus 1, or 31 basically bit number, to what? To the +2 to the 31 minus 1, right? So if I use my calculator and I calculate for you 2 to the power what? 2 basically to the power 31. This is the number minus 1. So it's 2 billion, right? So what a signed integer can basically get is anywhere between negative 2 billion to positive 2 billion. It can store those numbers. If your number is more than 2 billion, 5 billion, 100 billion or something, you cannot define it as a signed integer, okay? You're gonna get the problem of narrowing, which I'm gonna talk about it soon in this video. But make sure that the limits of storage for a signed integer is negative 2.1 to positive 2.1 billion or something, right? On the other hand, for unsigned integer, you can go between 0 to 2 to the 32 minus 1. So this time you have twice as big as that number, right? So you go to 4.29, 4.3 billion. So your numbers are going to be anywhere from 0 to 4.3 billion if they are unsigned. Short means they only have 16 bits, so clearly they have a smaller set of numbers to store. And then we go to long and long. Long is you have 32 bits, so quite a bit, it's similar to integer, but long is 64 bits. So now you can store very, very large number. And if my calculator can give me that number, let's see if it does, 2 to the 63, right? You see, that's your limit. Your limit is now what? It's 9 million billion, right? 9 million times billion, or 9 times 10 to the, what is it? That's 9, 12, 15, 18. That's 9 times 10 to the 18, right? That's a huge number. You most probably are not going to deal with numbers bigger than that. You have decimals now. Float is a decimal that has 32 bits. You have double that has 64 bits, so here is when you have a lot more decimal places. And you have long double that is 80 bits, so you can store numbers with a ton of decimals. By the way, as I told you last time, pi, remember pi 3.14? That is not a number that is recognized in C++. You have to use MPi. The same with Euler number, okay? Euler number 2.718, that's also not stored. You have to define it if you want. What is the problem here? The problem is, look at these two. I'm using a variable, and then it seems like I'm using the same variable, but I'm what? I'm changing it. Do you see that? So that's not a good habit. You cannot use the same variable and then change its type. That's the same thing I said do not do. So make sure you give it some different name. Maybe this one, call it EE. So at least EE is different from what? E. Make sure you do not redefine a variable in the same scope twice. You're going to get error, and do not change the type of any variable. Okay, so you make sure that error is not happening. And the other thing that I always ask my students to do is do not use II and JJ. Do not use I and J, I'm sorry. Use II and JJ. But that is for MATLAB, where I and J are used for complex numbers. In C, when you want to define complex numbers, it's a little bit different. You don't use I and J. So here in C, C++, if you want to use I and J as variables, that's okay. But based on the habits that I have, I still call them II and JJ. Then I have Boolean operators that can only be 0 or 1, true or false. And I can exactly give them a value of true or a false. Or I can define them using some logical operator, right? Or basically arithmetic operator. So here I'm saying L equals to what? 2 less than 4. Hey, is 2 less than 4? Yes, so that is, this statement is true. So L is going to be what? True. What about this? This last one is interesting. This is called auto. And you might say, what kind of variable is auto? And auto is a variable that you might not necessarily know what kind of variable it is, but you're allowing what? You're allowing C++ to determine the type of it. Why am I doing this here? Well, 3.6 is a number with decimal. E is a number, let me use EE. So EE is a number without decimal, right? It's a short integer, and 3.6 is a number with decimals. So here I'm mixing two different types, integers and shorts, right? Or well, float. I'm mixing up a short integer and a float. What is going to be the type of the output? I'm allowing C++ to determine that for me. Okay, so here we learn all different types of variables, right? Now, one thing I told you is do not declare a variable twice within a scope. So here, if I uncomment this part and I declared f to be this number long, now I come back and declare f to be an integer with a different number, would I get an error? And you see I do. It says conflicting declaration int f. Because I called it a long integer, now I call it just a regular integer. So that is conflicting. Now you might say, what if I change this to long? Would I get an error? So don't change the type of it. Okay, what about that? Well, you see, I still get an error, right? I did not change the type, but I'm declaring the variable twice here. And I should not within the same scope. You might say, what if I get rid of the long? Now, would I get error? No. Why? Because I'm declaring it once. Here, I'm just changing the variable's value. I'm assigning a different value. I'm not declaring it again with a new type. So ideally, this guy should not give me an error. And you see it does not. Okay, so when you put that variable type behind it, that's where you would get an error. And you're declaring it. So assignment is okay, but declaration is only allowed once, even if the type is not changed. What about constants? Constants are similar to the variables, but in fact that you have to declare them, you have to say what type they are, you have to give them some number, but the difference is, as the name says, you are not supposed to change these values, right? You define them once and you never change them. So they are constants, they are not variables, as clearly the name says. So if you want to create a constant which you're not going to change, before the type of the variable, you use the keyword const. That's the first thing you do. The second thing is, when you declare a constant variable, you have to assign it right there. You cannot declare it and then give it a number, right? Here, I can easily do that, right? I can go ahead and say long f, right? Don't give it any number, and then come here and then give it a number. So you don't have to assign the variable right when you declare the variable. This is declaration, this is assigning. I don't have to do them like all of these in the same line. I can do it in two separate lines. Look, there is no error. But for a constant, you cannot do that. For a constant, if you declare C1 in this line, you have to assign it right away. You cannot do something like this. Say, hey, constant integer C2, but in the next line you say C2 equals 4. If you do this, you're going to get an error. So you see right now I have no error, but look at this. Right? Now look, you are going to get an error here. You see? It says uninitialized constant C2. You defined C2, but you didn't initialize it. You didn't assign it right here. You did it in the next line. That's not acceptable. Okay, so keep that in mind. The other thing is, as I said, it's a constant. You give it a number. So of course, if I go ahead and change the value of that constant afterwards, what's going to happen? Well, of course, I'm going to get an error because I'm saying this guy is constant and it's 5. Then I say, no, it's 3. Well, if I know I'm going to change it, I have to call it a variable, not a constant. So definitely, you cannot change what? The value of a constant after initial assigning. What else do we need to know about these variables and constants? If you want to know the type of a variable, you can use the command type ID, pass to it the variable, dot name, open parentheses. That's a method for this command here, for this object. And this is going to give you the type of the variable. So m here, remember, we allowed this variable m we allowed it, the type of it, to be determined automatically by C++ because we were combining short and decimal float. So what is the type of m at the end of the day? I know C++ determined that. What is it? I want to know the type of it, so I use this command here. And this should allow me to find the type of what? The type of m. So let's take a look. So it says the type of m is, let's find it, is D here. And D means what? D means double. So when it combined the short with the float, it converted the result to a double. So the type of m is D. D stands for double here. Okay, so this is determining the type of a variable. What about size of the variable? How many bytes is the variable? You can use the command sizeof. So you say sizeof and then you pass the variable. So here I want to know the size of C1 and I want to know size of A. And if you look at one, A is an integer variable and C1 is a constant integer. So one of them is an integer variable, the other one is an integer constant. And their magnitudes are similar, 2 and 5. So what is the size of each one? You see, one of them is 4, the other one is also 4. So the fact that one is variable, one is constant, is not going to affect the size. Okay? So that's the command sizeof. What else? The other thing we want to learn about variables is narrowing. Narrowing is when you give a value to a variable that is beyond those thresholds, beyond the limits that it can store. So here I'm saying this number here, which is basically 4 billion, I want to call it an unsigned integer. But remember, when we talked about unsigned, we learned this number can only go positive, negative 2.1 billion. This number is 4 billion, right? Or sorry, it's unsigned, so it can go to 4 billion. And this number is very similar to that threshold, except one bigger. Look at that number, 96. Remember, when I used my calculator, it was 2 to the power 31, or 32, I'm sorry. 2 to the power 32, and then minus 1. So this number was the maximum it could hold, and this guy is exactly like that, one bigger. So this number is 1 unit bigger than the maximum threshold. Well, if I store this, which is 2.32, if I store it as an unsigned integer, what's going to happen, right? If I call this an unsigned integer, right? By the way, you can just call it unsigned. Would I get this number back? Or since this number is more than the maximum I can store, something would happen to it? Well, let's find out. So look at how much this guy is stored as. It's stored as 0, right? Because your number here is anywhere from what? 0 to this minus 1, which is this one. So we can only store that much. So when the number goes to this plus 1, what happens? It comes back and start from here again. So plus 1, it comes back and make it into a what? Make it into a 0 again. Right? If this number was plus 2, it would store it as a 1. If it was plus 3, it would store it as a 2. And I can check that for you, right? So here, let's add a 2 to this. Make it 8. What do you think? Right? It should show a 2, right? Let's see. Here. See, it's 2 units more than the maximum number, so it is stored as 2. And this problem is called narrowing. So if we want to make sure we can avoid narrowing, there is a way we can skip it. How is it that we can skip? Is by using braces around the number when we assign it to the variable. What happens when we do that? If we do this, what we are asking C++ to do is not only assign this, check for me. Check this number against the maximum of this type of variable. If this number is outside the range, instead of storing it in it as a wrong number, you throw an error at me. Don't store it, give me an error and say, hey, this number is out of the bounds. Right? This way I know I messed up somewhere and I go and fix it. So if you don't know these limits, if you don't know these thresholds, right, these guys, if you don't know them and you want to store something, either go and look it up or use these braces and you make sure that it gives you an error if it's out of bound. Look here. You see? It gave you an error right away and say, hey, this number was definitely a problem here, right? So you definitely do not want that to happen, so you go ahead and fix that narrowing error. So these braces would help you. And the last thing is typecasting. Sometimes you want to change one variable from one type to another. So for example, remember this number E, the Euler number that I defined, 2.718? You want to change it from what? A float, which is decimal, to an integer. So how would you change it from a decimal to an integer? Use this guy here. And you say, change this E from float to what? To an integer. So you put the new type inside parentheses and put it before the variable, and then call it E, which is typecasted into integer. And it's going to be an integer variable, of course. And now, what is the integer version of 2.7, right? What is the integer version of that? Go ahead and show it to me. And look at the integer version. How much is it? It's 2. So what did it do? It killed the decimals for you. So when it does that typecasting here, it's not going to do rounding. It is going to do truncation of the decimals. It doesn't care if this decimal, first decimal, is more than 0.5 or less than 0.5. It just removes the decimal, do truncation. Okay, it doesn't do rounding. But you see, I could convert my decimal number into an integer number, and this is called typecasting. And you can convert any variable into another variable. So hopefully you learn useful material about changing variable types, about the narrowing issue, about the size of the variables, about constants, about variables, about the type of the variables, and so on, and what kind of variables in general we have in C++. So I will see you in my next video. Thank you.